let's say n is given as 5 and k is given as 3. And if I consider 0 based indexing, I know that we have to return the answer in 1 based indexing, but for the explanation, let's start our illustration with 0 based indexing. So n is equal to 5 means we have 5 persons sitting in around a circular table. So let's say this is person number 0, this is 1, this is 2, this is 3, and this is 4. Total 5 person here we have. And in each iteration we are killing third person starting from the 0th person. What is the third person which I will kill so starting from 0, the third person is first, second and third. This is the kth person, so I will kill this person, and after that I will be left with 0, 1, 3 and 4. And after that the sword or pistol or whatever it is will be handed over to the person next to the person which is killed. So now the counting will start from this 3. So this counting will start from this 3, and I have to kill third person. So this is 1, 2, 3. The third person is 0 this time. So after killing this 0, I will be left with 4 here, 1 here and 3 here. Okay. Now the counting will start from the person which is next to the person killed. So after 0, the next person is 1. So counting will start from 1 and 1, 2, 3. So this time 4 will be killed and I will be left with 1 and 3 only. And after that counting will start from 1, and if I count 3, 1, this is 2 and 3 again, this is 1. So this 1 will be killed and I will get 3 as the last person which is standing and which will be a safe person. So our answer is 3. Now what we can observe here is that in each iteration my n is getting decreased by 1 unit. So now if I have n, the next iteration I have n minus 1, then n minus 2, till I am left with only 1 person. So here you can see initially we started with 5 person in this circular table, then I left with 4, then 3, then 2 and then 1 person only. So this pattern is giving us a feel of recursion, because in recursion what we do, we decrease our input. The input gets smaller and smaller in each recursion call, and instead of solving the big problem we solve a smaller sub problem. So instead of solving for n, we will solve for n minus 1, and instead of solving for n minus 1 we'll solve for n minus 2, and so on till we get 1. And the answer which I get from a smaller problem is propagated back to the bigger problem. It's converted and it is mapped to the bigger problem. So what we can say here is that if I have given n is equal to 5 and k is equal to 3, I have 0, 1, 2, 3 and 4. What happened in the next iteration? This 2 will be killed and I will be left with n is equal to 4. 4% will be left in the circle, but k will be still 3. K is not decreasing. So I can solve this problem as separate. I can call it as a new problem. And in this new problem, I have n is equal to 4, k is equal to 3. So what I'll do, I'll place 4%. And you know that after killing this 2%, the counting will start from this 3. So instead of calling it 3 again, I'll call it 0. I'll renumber all the people, and 0, then 1, then 2, then 3. So this is my problem, where here I've given n is equal to 4 and this is the first person. So in this original problem, first person was this, where counting is starting, but in a smaller problem, the first person is this. So 3 is changed to 0, 0 is changed to 2. We have renumbered them. Okay. So if somehow I solve this problem, I can map answer of this problem to the answer of this problem. We know that after solving this new problem, we get this 0. Why? Because here we can see that if we keep on killing, the third person get killed, and here the third person is mapped to 0. Third person will remain safe at the end. And here what we did to 3 is mapped to 0. So we can say that if I keep on solving this problem, the answer will be written as 0. But what I have to return the answer in my original program, the answer of original problem is 3. Okay, answer of original problem is 3. So I have to map this 0 to 3. Now how I need a mechanism through which I can map this 0 to 3. If I observe, I can say that this 0 number is shifted by k unit. If k is 3, then it is shifted by 3 unit. So 0, then 1, 1 unit, second unit and third unit. So 0 is shifted here by 3 unit. So by this, every number, this 1 is shifted by 3 unit, 1, 2 and 3. So here 1 is shifted here. So here we can see 1 is here in this new problem. So every number is shifted by 1 in this new problem. And if you observe closely, you can say that any index from the new problem, if I add k to it and take modulo with n of original problem, I will get the original indexing. Add 3 to this 0. 0 plus 3 is 3. So this original index is 3. And 3 modulo 5 is 3. So add 3 to this 1. 1 plus 3 is 4. So original index was 4. Add 3 to 2, you will get 5. And 5 modulo 5 is 0. So 0 here. So why we are doing modulo here? Because we can extend the maximum index. We can go beyond the maximum index. So we don't want to do so. We want to fall back into the same indexing again and again. Okay. So if I add 3 to this 3 3 plus 3 is 6, and 6 modulo 5 is 1. So this is the 1 index. So what I can say that whatever the answer I'm getting from my sub problem, so I will solve instead of solving for n comma k. What I'll do instead of solving for n comma k, what I'll do, I'll solve for n minus 1 comma k. Okay, and whatever the answer I'm getting from here, I will add k to it and take modulo of it with n. That will be my answer to this bigger problem. I can say that solving n comma k is same as solving n minus 1 comma k, and the answer I'm getting from this problem, I'll add k to it and I'll take modulo of this answer with n. This will be my answer to this problem. Similarly, for n minus 1 comma k, I'll go for n minus 2 comma k. So I'll keep on reducing the input, and I can't do this infinitely. I can't reduce my n infinitely. I need some terminating condition. So when will I stop? I will stop when n become 1. And what will be my answer in case of n equal to 1? What is the answer when there is only one person sitting around round table? In that case, answer is that 1 only. If it's a 0 indexing, then I can say it's 0 index. So if only one person is sitting around the round table, then I don't need to, whatever the value of k, I don't need to kill anybody, because this is the only person which survived. So in the recursion, this will be my terminating condition. Or I can say base condition. So what will I do? I need to solve for n comma k. So n is the number of persons sitting around a round table, and k is the kth person that is to be killed in each iteration. So what I'll do, I will return an answer recursively. So whatever answer I get for n minus 1 comma k, I'll add k to it and take its modulo with n. I will return that. And what if n is equal to 1? Then I will not further decrease that 1 by 1 unit, because if in the case of n is equal to 1, then I don't need to reduce my input further, and in that case I can just simply return 0. So this function will do my job, and this will return the answer with 0 based indexing. So on the GFG portal, in the problem given, we have to return the answer in 1 based indexing. So my answer which I have to return is solve n comma k plus 1. So whatever answer you will get from here, just add 1 to it, then it will be converted into 1 based indexing, and that's it.